Today we are going to discuss some of the problems on frequency response of LTI system and solution of difference equation of discrete time Fourier transform. First problem, obtain the frequency response of a discrete time LTI system represented by the impulse response h of n is equal to half to the power n into E of n. The frequency response of a discrete time LTI system is given by the DTFT of h of n, that is h of e power j o is equal to summation n is equal to minus infinity to infinity h of n into e power minus j ohm n. So it is given half to the power n into E of n. So summation starts from summation n is equal to 0 to infinity half into e power minus j ohm to the power n. Therefore, frequency response h of e power j ohm is equal to 1 divided by 1 minus half into e power minus j ohm. Next problem, obtain the frequency response of a discrete time LTI system with impulse response h of n is equal to 1 by 8 into 7 by 8 to the power n into E of n. The frequency response is given by h of e power j ohm is equal to summation n is equal to minus infinity to infinity h of n into e power minus j ohm n, which is equal to 1 by 8 summation n is equal to 0 to infinity 7 by 8 into e power minus j ohm to the power n. Then frequency response h of e power j ohm is equal to 1 by 8 into 1 divided by 1 minus 7 by 8 into e power minus j ohm. Next problem, obtain the frequency response and the impulse response of the system having the output y of n for the input x of n as given below. X of n is given half to the power n into u of n, and y of n is given 1 by 4 into half to the power n into u of n plus 1 by 4 to the power n into u of n. So it is given x of n is equal to half to the power n into u of n. We can call it as equation number 1, and y of n is equal to 1 by 4 into half to the power n into u of n plus 1 by 4 to the power n into u of n. We can call it as equation number 2. So taking DTFT of equation number 1, we get x of e power j ohm is equal to 1 divided by 1 minus half into e power minus j ohm, and taking DTFT of equation number 2, we get y of e power j ohm is equal to 1 by 4 divided by 1 minus half into e power minus j ohm plus 1 divided by 1 minus 1 by 4 into e power minus j ohm. Therefore, the frequency response h of e power j ohm is equal to y of e power j ohm divided by x of e power j ohm, which is equal to 1 by 4 plus 1 minus half into e power minus j ohm divided by 1 minus 1 by 4 into e power minus j ohm. Then h of e power j ohm is equal to 1 by 4 plus 1 divided by 1 minus 1 by 4 into e power minus j ohm minus half into e power minus j ohm divided by 1 minus 1 by 4 into e power minus j ohm. Then by taking inverse DTFT, we get impulse response h of n is equal to 1 by 4 into delta of n plus 1 by 4 to the power n into u of n minus half into 1 by 4 to the power n minus 1 into u of n minus 1. This is the required answer. Next problem. Obtain the frequency response and the impulse response of the system described by the difference equation y of n plus half into y of n minus 1 is equal to x of n minus 2 into x of n minus 1. It is given y of n plus half into y of n minus 1 is equal to x of n minus 2 into x of n minus 1. So by taking DTFT on both sides of above equation, we get y of e power j o plus half into e power minus j o into y of e power j o is equal to x of e power j o minus 2 into e power minus j o into x of e power j o. Therefore, the frequency response h of e power j o is equal to y of e power j o divided by x of e power j o is equal to 1 minus 2 into e power minus j o divided by 1 plus half into e power minus j o, or h of e power j o is equal to 1 divided by 1 plus half into e power minus j o minus 2 into e power minus j o divided by 1 plus half into e power minus j o. Then taking inverse DTFT, we get impulse response h of n is equal to minus half to the power n into u of n minus 2 into minus half to the power n minus 1 into u of n minus 1. Next problem, obtain the difference equation description for the system having impulse response h of n is equal to delta of n plus 2 into half to the power n into u of n plus minus half to the power n into u of n is given h of n is equal to delta of n plus 2 into half to the power n into u of n plus minus half to the power n into u of n. By taking DTFT on both sides of above equation, we get h of e power j ohm is equal to 1 plus 2 divided by 1 minus half into e power minus j ohm plus 1 divided by 1 plus half into e power minus j ohm, or h of e power j ohm is equal to y of e power j ohm divided by x of e power j ohm is equal to 4 plus half into e power minus j ohm minus 1 by 4 into e power minus j2 ohm divided by 1 minus 1 by 4 into e power minus j2 ohm, or minus 1 by 4 into e power minus j2 ohm plus 1 into y of e power j ohm is equal to minus 1 by 4 into e power minus j2 ohm plus half into e power minus j ohm plus 4 into x of e power j ohm. Taking inverse DTFT, we get minus 1 by 4 into y of n minus 2 plus y of n is equal to minus 1 by 4 x of n minus 2 plus half into x of n minus 1 plus 4 into x of n. Next problem. Obtain the difference equation for the system with the frequency response h of e power j ohm is equal to 1 plus e power minus j ohm divided by 1 plus half into e power minus j ohm into 1 plus 1 by 4 e power minus j ohm. It is given h of e power j ohm is equal to y of e power j ohm divided by x of e power j ohm equal to 1 plus e power minus j ohm divided by 1 minus half into e power minus j ohm into 1 plus 1 by 4 into e power minus j ohm, which is equal to 1 plus 3 by 4 into e power minus j ohm minus 1 by 8 into e power minus j2 ohm divided by 1 minus 1 by 4 e power minus j ohm minus 1 by 8 into e power minus j2 ohm. Therefore, y of e power j ohm into 1 minus 1 by 4 into e power minus j ohm minus 1 by 8 into e power minus j2 ohm is equal to x of e power j ohm into 1 plus 3 by 4 e power minus j ohm minus 1 by 8 into e power minus j2 ohm. Then by taking inverse DTFT on both sides and using time shift property, we get y of n minus 1 by 4 y of n minus 1 minus 1 by 8 y of n minus 2 is equal to x of n plus 3 by 4 into x of n minus 1 minus 1 by 8 into x of n minus 2.